Okay, so let's just go over a couple of these, all right? Not the whole thing. Number one, what's the vertex? You always start with the vertex. That's the first thing you do. Yes, you always look at your h and your k, and obviously h, you're going to think opposite, which is -2, and the k value is 0. There is no number that's being added or subtracted at the very end. So that's the first thing you state. That's the first thing you graph. Everybody go to -2, 0, put a dot right there. After that, you're going to draw your axis of symmetry, which is a vertical line going right through, and I always do it a green dotted line on my videos, goes right through that vertex, and it will be the equation x equals the x value of your vertex, which happens to be -2. So that's the axis of symmetry equation. What's the pattern that we're going to use? Well, the pattern, because the a value is 1, it's the same exact pattern that we were using on the notes, which is 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. These used to be coordinates on the parent graph. Now we're just going to use them as a pattern to produce the same exact width on the U-shaped curve from that vertex. Okay, so this is a +1 as the a value, so it is going to be opening up. And let's use the pattern. 1 over, 1 up. Let's put a dot right there. Let's go back to the vertex and go 2 over, 1, 2, 3, 4 up, and put a dot right there. And then if we go back to the vertex and go 3 over, 9 up, I'm going to be off the graph just by 1. So I might as well plot it. You don't have to, but since it's only off by 1, I want to plot it right there, 1 unit off. And of course, you use that axis of symmetry, that green dotted line, to reflect those lines to the other side. That way it makes it super easy to graph. And again, how do you reflect it? Just count. 1 unit, 1 unit. 2 units, 2 units. 3 units, 3 units, same level. So that's our parabola. Put some arrows on it. Go through those points carefully. Make sure those arrows are pointing to the ones that are off the graph. The domain, x equals all real numbers. Any parabola will always have the domain x equals all real numbers. It's like a free point if I ask you that. The range, it's either going to be above or below a certain value, and as you can see, this is at the y value of 0, and it is above. So how do we stay at 0 or above? You're going to say y is greater than or equal to 0. How about the x-intercept? Where does it cross the x-axis? Oh, that touches the x-axis at -2 and at no other value. Here's the x-axis. It touches right here at -2. How about the y-intercept? Where does it cross the y? It crosses right here at 1, 2, 3, 4. So the y-intercept is 4. Now the transformation, this is just something I want you to start thinking about, and let's write it down here. What happened if you were to think of the original parent graph, which has the origin as the vertex as the origin? What happened to the original parent graph compared to this new one? It got shifted 2 units to the left. So I would like you to write that down on the transformation. Shift 2 to left. And that's about it. Let's try number 3 right here. What's a vertex?
-2, 3.
Think opposite on h, -2, take k for what it is, 3. Perfect, right? H, -2, k is 3. Think opposite on h, take k for what it is. Could somebody give me the equation to the axis of symmetry even before graphing it? X equals what? The -2, the x value of your vertex. Super easy. How about the pattern that we're going to use on this guy? What's the pattern? 1, 1, 2, 4, 3, 9. That's because the a value is 1, and we got that pattern from the original parent graph. How about the domain? And we haven't even seen this parabola yet. What's the domain on this thing? It's always going to be x equals all real numbers. So look at all that information that we already have from the parabola, even without seeing the parabola. It's pretty crazy, right? If you understand your a, your h, and your k, you could state a lot of information about a graph that you haven't even seen yet. Okay, so let's go to the coordinate -2, 3, -2 on the x, 1, 2, 3 on the y. There it is. That's my vertex, -2, 3. What's the next thing to do? Next thing to do is to draw your axis of symmetry right through it. And that axis of symmetry, we said it was the equation x equals -2, the x value of our vertex. And we are going to use the pattern 1, 1, 2, 4, 3, 9. But the thing is, am I going to be going 1 over, 1 up? Yes or no? No. Why not? Why not up? The A is negative, which means you're going to go 1 over, 1 down. All right. Now, some people like to change the outputs to negatives. I just say recognize whether it's opening up or down, and then use the pattern to travel in that direction. So 1 over, 1 down. Let's put a dot right there. And then go back to the vertex and go 2 over and 1, 2, 3, 4 down right there. Then go back to the vertex and go 3 over, 1, 2, 3, and 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope I counted that right. Did I? Okay, and now let's map it over to the other side of the axis of symmetry. A point right there, a point right there, and a point down there. I mean, seriously, this is a very difficult section, but it's really easy if you understand your A, your H, and your K. I mean, honestly, I graphed this thing without doing any math. I mean, imagine if I were to make an input-output table, if I plug in a 0 here, do that math, square it, add it, negative, it gets all confusing. If you know that the A value is positive or negative 1, you could use a pattern 1, 1, 2, 4, 3, 9, and then you could answer the rest once you have it. So what's the range of this guy? What's the range? Y is less than or equal to what? 3. Perfect. Okay, now right here on the x-intercepts, this is weird. It doesn't cross the x-axis at nice locations. So I don't want to be, just give me an estimate. So let's do this. Put a squiggly line. And we're going to say that this first one, it's not at negative 1. Let's say it's at negative 0.3. This is just an estimate. Negative 0.3. And where else does it cross? It crosses at negative 1, negative 2, negative 3. Not quite negative 4, so maybe like negative 3.7 or something like that. Negative 3.7. So these are approximations. Later on in the class, I want to be like, what's the specific value? And you'll be able to, we'll do that later. But right now, just an approximation. How about the y-intercept? Where does it cross the y-axis? At negative 1. And how about the transformation here? Everybody write this down quickly. It got reflected over x axis. That means that it opens down. And it got shifted, shift 2 to the left and 3 up. Thank you for your time. Again, the transformation that we want to describe is that it got reflected. The parent graph would normally open up here. It opened down. That's why it's opening down. So the first thing we say is that it got reflected over the x-axis. And then after it opens down, it got shifted 2 to the left and 3 up. So that's the complete description of the transformation from the parent graph to this new parabola opens down and shifted 2 to the left and 3 up.